Today we are very happy and honored to have as the colloquium speaker Professor Peter Buschneider from the University of Heidelberg. Peter is a well-known scientist in two areas of astrophysics. One is the area of solar and stellar atmospheres. In fact, the first time we met was a long time ago at Harvard, when Peter was a visiting professor then at Harvard, and I was there, and working on stellar astrophysics. And then the second subject where Peter works is astrobiology. This is the area which has to do with this subject Peter is talking to us today. The subject is very popular, of course. Everybody is interested to know about the prospects of having contact with some extraterrestrial civilization. Talking in the newscast last week was saying that it would be maybe a disaster if we ever guess it. We don't know if it's positive or negative, but it would be the greatest evolution in our society. In any case, Peter also has written a book for Springer, Intelligent Life in the Universe. So he has worked a lot on this subject as well. The other thing I want to say is that this semester, Professor Buschneider is giving a course for the graduate students, not only of the astrophysics group, but graduate students who come from other sections on this topic. And we are really obliged to see that Peter came from Heidelberg to teach us here the latest news on this subject. But it's very kind of him to be with us for this month and give us these lectures. So we thank him very much for giving this series of lectures to the graduate students and for telling us in 1 hour the resume of the course, I guess, yes, today. So, Peter, you have the floor, and thank you very much for teaching us here and for coming to the University. It is our pleasure, and we really appreciate it.
Well, thank you very much for this very kind introduction, and I must say that I am really utterly honored to be able to speak and give a lecture at this famous place, Athens, where luminaries like Plato and Aristotle gave their lectures. So I feel very small in this wonderful place. Unfortunately, I'm not a great expert in the computer details, so you have to suffer this type of display. I want to talk to you about intelligent life in the universe, myth or reality. It has been known, man has always believed that there are intelligent non-human beings around. Gods, angels, demons, centaurs, UFOs, and so on. What does science say about this? Unfortunately, we have to tell that no contact with extraterrestrials has ever been established, no trace of their existence has ever been found. But if you ask somebody, a colleague in astrophysics, he will tell you that it's practically certain that extraterrestrial intelligent civilizations exist. There is only a debate how many of them exist. This is the big debate. The reason why you can be so certain is based on 3 arguments for the existence of extraterrestrial intelligent civilizations. One is the so-called astronomical argument, which tells you that there is a very large number of Earth-like planets in the universe. And the second argument is, once you have an Earth-like planet, it is extremely certain, almost certain, that life and also intelligent life develops on it. Now, if you take these two arguments together, then you have the conclusion that there are many extraterrestrial civilizations, and the problem is now, why don't we have contact? This is a big problem. This is called Fermi paradox. And an argument I'm going to give you is, you can get an answer to this question if you think more carefully about the nature of extraterrestrial intelligent beings. Let me now first show you this mean annual isotherms on Earth, this map, and you see the Sahara here in red, where the temperatures are above 25 centigrades annually over the whole year, and there is very little life in this area, both human or plant or animals. Also in the Arctic, where the mean annual temperatures are below 0 degrees centigrade, you have practically no life. And this tells you that life lives only in a certain zone of temperatures, and the temperature can vary at most because the temperatures are derived from the sun. Without the sun we would not have life. The solar radiation flux, and the solar radiation flux from the Sahara to the Arctic varies at most by a factor of 2, because cosine 60 degrees is 1/2. So now we ask the question, or make a thought experiment. Let's say here is the Earth. How far can you bring the Earth closer to the sun and still have life on it? As the radiation flux goes as 1 over the square root of the distance, you can go to 0.7 astronomical units, and then you have this factor of 2, in which case the Sahara would expand to all the way to the Arctic. And you could move the Earth away to a distance of 1.4 astronomical units. In this case, then the Arctic would move down to the equator, and this region, being a factor of 2 in radius and a factor of 4 in luminosity or flux, is the so-called habitable zone. Then let us assume, where is this in the solar system? You find it happens roughly to be the distance between a Venus orbit and the Mars orbit. Here is radii of these orbits. This is the habitable zone. In reality, you want to have such a habitable zone, and you have a planet in here for all the time that life is on Earth, 4 billion years. And as the sun is increasing in luminosity constantly, this habitable zone changes, and also there are instabilities of the atmosphere of the Earth, and that means the real habitable zone is much smaller. It is a small strip of 0.95 to 1.01 astronomical units around the Earth's orbit. So this is a habitable zone, but there is also another problem. That has to do with the action of the tides. Here is the Earth at a distance of 1 astronomical units, and when you bring the Earth closer to the sun, the tides that are caused by the divergence of the gravitational field and go to the third power of the distance, quickly increased, and there is a dangerous radius, a so-called co-rotation radius, at 0.6 astronomical units, where in about 1 billion years, the spin rotation of the planet will be braked so much that it will show its one face always to the sun and the other part always away from it. In that case, the oceans on the solar side will be evaporating and deposit as ice on the backside, which would never get any energy. And therefore, in a short time, all the oceans would vanish and there would be no life on Earth. So you have to demand that a planet live outside this co-rotation radius. Let us now look at other stars, and the stars are classified by the spectral type. And for historical reasons, it is written in letters, and you remember this old riddle of Russell, "Oh, be a fine girl, kiss me." This way you can remember. Or if you are a woman, you say, "Oh, be a fine guy, kiss me." So this is a spectral type. It's essentially a temperature classification. O stars are very hot, 35,000 degrees. And therefore, the habitable zone, which you see is a factor of 2 in radius, is far out at 400 to 800 astronomical units. The G star we have already seen, like the Sun, you have in 0.7 to 1.4, and in M stars, which are quite cool, 2,600 degrees surface temperature. This is called 0.5. Spectral type, or M.5, you have here this habitable zone 0.06 to 0.12 astronomical units. Now, you have to have, in order to, if you want intelligent life, you know that on Earth it took 4.6 billion years to develop intelligence. Intelligence is only around, intelligence, human type intelligence, only about 2 million years. So you have to demand a similar amount of time of development on another planet. So you see, F stars, they live only 4 billion years. The time is not enough to develop intelligence, and even less so on O stars, where they live only 1 million years. So, so these spectral types are excluded. You will not have planets in the habitable zone here which can produce intelligent life. But this doesn't matter much, because these stars are not very frequent in the universe. In the galaxy, F stars are the most frequent, with 4% of all stars. But let us now look at the co-rotation radius. And you see that, for instance, for M stars, the co-rotation radius is at 0.4 astronomical unit, but the habitable zone far inside. So if you have a planet here, it will be co-rotating, and there can be no life on it. And also on K stars, it's the same thing, yeah? But here now you have a problem, because 72% of all stars in the galaxy are M stars and 14% are K stars. So only the G stars have the conditions right, that the habitable zone is outside the co-rotation radius. Now, how big is the probability that by chance a terrestrial planet will be in the habitable zone? And for this, we have to look a little bit at star formation. You know that we live in a spiral galaxy. Here you see the nice spiral arms. Ours is a bar spiral, but one cannot see it from the outside. But it's similar to this, and you see here these very dark clouds. These are dust clouds, which are associated with giant molecular clouds, and these are seeds of star formation. In the following picture, you see from the radio observation, you see in the Milky Way one of these giant molecular clouds. Here is the name of it, and here is the size. And you see from the radio lines the extent of this, and also where it's very cold. Here is a region which is extremely cold, and these cold regions by some perturbation start to collapse under their own gravity, and then when the collapse starts, it changes the radius by a factor of 1,000, and because you have conservation of angular momentum, and the little rotation and everything rotates in the galaxy a little bit, you know, this gets strongly amplified. And because this is not homogeneous here, there is a number of clumps. This collapse is not homogeneous, so you get essentially many blobs, and most of this rotational motion is going into orbital motion and of these blobs. So you get, when you form a star, you don't get one star, you get a whole star cluster. And one of these blobs then collapses to form such a thing, and because the collapse goes easily parallel to the rotation axis and is impeded perpendicular to it because of the conservation of angular momentum, you get these pancake-type accretion disks. Now here in the next picture I show you a recent photograph of the Cone Nebula which shows you such a star cluster in the process of formation. This is a Spitzer Space Telescope exposure, and these are only the brightest stars. You have hundreds of weaker stars. So you see the star formation goes on with the formation of such star clusters. Now, there have been theoretical calculations to form a star from an accretion disk, and this is shown here in this figure by Hughes 1992, and there are some more recent calculations which essentially agree with Hughes, and they are displayed in this diagram. Here on the ordinate you see the mass, and as I told you, we are only interested in G stars, therefore we are only interested in this one line, and here is the distance in logarithmic scale in astronomical units. Now you see two interesting lines, the green line and the red line. And the green line, to the left of the green line, there is no planet, because there the temperature is so high in the accretion disk that the dust is evaporating, and so you don't form any planetesimals and planets. And then there comes the range of terrestrial planets, and here you have 5 of them. And then there is another line, this red line, and this is the so-called ice formation boundary or ice line. And here the temperature in the accretion disk going away from the central object has fallen to very low temperatures, so about 150 Kelvin, and there ice falls out from the water vapor. And water vapor is a very frequent molecule in these accretion disks, and therefore a lot of ice crystals fall out. Actually, so many that the terrestrial planets forming here have masses of the order of 5 to 10 Earth masses. And this mass is then so big that it also attracts volatile gases like hydrogen and helium, and these are the most abundant gases in the universe, and therefore they very quickly, in a so-called runaway accretion, form gigantic planets, the Jupiter-type planets with 300 Earth masses. So beyond this ice formation radius, you form Jupiter planets. And out here you have these Kuiper belt objects, and they have little mass because here the end of the accretion disk comes, and there is not enough mass to collapse any great objects. But we are not interested in these objects. Okay, so this is the thing. So you have a few terrestrial planets, and you have these large Jupiter planets. Now we are able to make a sort of a short calculation, very rough calculation, how many Earth-like planets would you expect. Let's say our galaxy has about 1.6 times 10 to the 11 stars, and we said already we can only use G stars, and then we have a factor 0.6 because you need a high metal abundance element composition, meaning population 1, chemical position, because otherwise the terrestrial planets would be not big enough. Like the moon, for instance, at Earth's orbit, it's ideal in a habitable zone and everything, but the moon is devoid of life. So you need a big enough planet. So population 1, chemical abundance, and then you have to multiply with a factor of 0.3, because 70% of all stars are multiple systems. So you double or triple and what stars, and if you have a planet around this, the conditions are not stable over a very long time, and therefore we exclude these multiple systems. And here now comes the probability that a star, a terrestrial planet, falls into the continuously habitable zone, which has this small width of 0.06 astronomical units. This is the distance of the ice formation radius. So this is the probability of one star, but we have, as you recall, we have 5 planets, 5 terrestrial planets from these theoretical calculations. I put here only 2 because of these 5 in our solar system. The outermost one did not even form a planet because Jupiter, the tidal interaction of Jupiter, prevented the asteroids of forming a planet. And Mars has 1/10 the mass of the Earth. But you would expect for a terrestrial planet to close to the ice formation boundary to have more mass than the Earth. Yeah? So you see, Jupiter prevented Mars of having more mass. Yeah? And also Mercury is too close to the Sun, and the Sun perturbed Mercury so much that it also didn't grow massive enough. So we have this factor 2 here, and then we multiply with a very bad factor 6% here. Because of recent observations, and we were talking about this just now, you know, Jupiters are found, but they are not there where they have been formed at the ice formation boundary, but they have been found all the way in distances even below the radius, the distance of Mercury. How does a Jupiter go that far in? One now knows that has to do with Jupiter migration. They migrate in, but you cannot do that easily because you have to conserve the law of angular momentum. And the way a Jupiter does this is by throwing out a lot of mass and planetesimals which are orbiting inside, throw this out, and this way it can slowly go in, and the whole angular momentum is conserved. So if you then multiply all this together, you find very roughly 4 million Earth-like planets in our galaxy, which you think is quite a lot, but if you compare to the original number, you find that only 1 star in 50,000 stellar systems has an Earth-like planet. But if you multiply this number with the number of galaxies, in our universe, you find a number of 4 times 10 to the 17 Earth-like planets in our universe, and I wrote out this number here in detail that you will get impressed, you know. This many Earth-like planets are around, and this number alone tells you that we cannot be alone. It's no possibility that we can be alone. Let us now come to the next step and ask, well, given an Earth-like planet, how probable is it that life develops on it? we have to go back to the formation of an Earth-like planet. Here you see the Earth, which formed 567 billion years ago, and here this it has first a liquid surface, and then that surface dries up, becomes stone, and then the ocean deposits on top of it, and so on. And in the following graph, you see the stages for appearance of life on Earth. This is when the Earth and the solar system got formed. One knows this from a meteorite that fell in Kazakhstan. Then 40 million years later, the moon formation occurred as a collision of proto-Earth with Theia, which was a Mars-sized impactor. A Mars-sized impactor to form the moon. And then 4.45 billion years ago, one knows that already oceans were on Earth, so it was cold enough and continents, and very likely there's a new paper in Nature in this year or the end of last year, which claimed that the first life living thing already happened at that time. But most people now believe that life occurred a little later, after the so-called late heavy bombardment. This was a time where there were huge numbers suddenly of asteroids impacting in the inner solar system on the moon. If you look at the moon, you see these gigantic mares, and they were all produced at that time by the late heavy bombardment, and you can find similar impacts on Mars and on Mercury. So the conventional idea is that just after this late heavy bombardment, the first living being arose on Earth, but was very different from today's life, and people try to reproduce this in the laboratory. There have been no fossils of this thing. The people think that the oldest living things, living organism close to us, being a single cell, prokaryote cell, called last universal common ancestor, was produced 3.8 billion years ago. And at this similar time, they find unusual isotope ratios of carbon in the so-called isolar formation in in the southern Greenland. But this is disputed by the guys who dig things there and bring them to the laboratory to measure these things. But it's confirmed that 3.5 billion years ago, first confirmed microfossils were around, and stromatolites, two different types of things. But these things must have had a long history before, so this 3.8 billion years seems to be quite good as a date. Now, how was the environment? There was intensive volcanism, hot, dusty, because of a lot of dust thrown out. You had frequent impacts of meteorites in those days, and you had a very thin crust, and the moon was 10 times closer, therefore you had 1,000 times higher tides. You had, by sequencing of bacteria, you find that at that age you must have heat-loving bacteria, so it must have been rather hot, like 35 to 40 degrees in the oceans, and halophilic acid-loving bacteria. You had UV radiation, static electricity, and this has all been reproduced in the laboratory. Let me now go on. Once you have life, it develops. So the first life, as I said, occurred about 4 billion years ago, a prokaryotic cell, and then 2 billion years later, it took a long time because life lived in the ocean 3.5 billion years, only in the oceans, and only since 500 million years did life also come up on the land. The reason of it being it took a very long time to develop the so-called eukaryotic cell, which has a nucleus and has various organelles like flagellae and so on. And this took a very long time to develop this very formidable hunter and this very nice eukaryotic cell. And then from that it took another billion years to develop multicellularity, and multicellularity is not only important because you amass a big body out of many cells, but the real important point about multicellularity is the specialization. Cells are specialized in skin cells, muscle cells, brain cells, and so on, and you form lungs and legs and so on. And that allowed animals like lungfish to come out of the water 390 million years ago in the Devonian, and then finally 2 million years ago to develop human-type intelligence. Now, intelligence, just 10 years ago, it was a dogma. You could read, you can still read in some older books that intelligence is something which is, does not occur very often. It's very seldom does it appear. And the great evolutionary biologists, both being, for instance, professors, long-time professors at Harvard University, were claiming that as intelligence is something which you would never find anywhere else. And it was only a chance that it ever formed on Earth. But this has been completely thrown out, and now evolutionary biologists believe that evolution occurred, the evolution of intelligence occurred in a broad manner in the animal kingdom. Already the fish are quite intelligent. Here I show you the Velociraptor. This is a dinosaur in the Cretaceous period, 80 million years ago. And this was already a quite intelligent being. It had the size of a turkey, and it had feathers but couldn't fly. But it had group hunting. One can see and find this by looking at fossil tracks, that they were ingenious in capturing prey with communal action by getting together, working together to kill something. And also they had communal breeding with clutches of eggs and so on. So this was an intelligent being. But the next much more intelligent beings are those with so-called mirror self-recognition. If you put a mirror in front of a cat or a dog, the cat and dog will not recognize that that animal looking out of the mirror is themselves. But there is a level of intelligence in some animals, and these animals do indeed recognize that they are what is in the mirror is themselves. And these are naturally chimpanzees, gorilla, orangutans, the great apes, but surprisingly enough, also so-called these raven-type birds and crows. And just recently, you can see in Google or so, in the newest literature, they are surprised how intelligent these type of birds are. They have a level of intelligence which is at a par with the most advanced primates. And also elephants and even dolphins, and here you also see a capuchin monkey who also recognizes itself. So this is, now let me come back to the evolution of human-type intelligence. It starts off about 6 to 7 million years ago, the so-called hominid evolution line leading to man. This is is a branching point between chimpanzee and humans. And one of the first ones of these hominids were the so-called Australopithecines. They were all upright walking since about 6 million years. And here this Australopithecus afarensis, also sometimes called Lucy, is 4 million years old, and in every aspect it was a habitual upright walker, but with a chimpanzee type head. I mean, it was more developed than a chimpanzee, but this was this also. And later, the Homo developed. Here I show you the Homo erectus 2 million years ago. It looked very much like us, and the brain was very much larger than this one. And it could also already use fire as a tool. And finally, 200,000 years ago, Homo sapiens arrived. So let me now summarize the two arguments. Astronomical argument, 4 times 10 to the 7 Earth-like planets in the universe. The biological argument, it is most likely that life and intelligent life develops on Earth-like planets. There is a conclusion, it is quite certain that extraterrestrial intelligent life exists. Now, when we are so certain about these things, we have a problem. First of all, how frequent are these societies? Why don't we have contact? This is the Fermi paradox. And what can we know? I think the answer is that we think about what we can know about these civilizations. So let me now come to this question. What do we know about extraterrestrial civilizations? Here I show you again the history of the universe. The Big Bang occurred 13.7 billion years ago, and then here the Earth, the history of the Earth is Earth formed 4.6 billion years ago, and human type intelligence developed only 2 million years ago, which is sort of the width of this broken line here. Now, if you assume that it takes an equal length of time from the formation of the system, the solar system, to the formation of intelligence, you can estimate when was the first intelligent life occurred in the universe. Now, the first Earth-like planet, population 1, chemical composition solar systems, formed about 10 billion years ago. 10 billion years ago, the first population 1 stars formed, and therefore, if you take the same amount of time to form intelligence, the first intelligent beings should have been around 5.5 billion years ago. So the question is, how do these intelligent beings, if they would still live today, what is the difference between them and us? Now, I think and claim nobody here on Earth can ever imagine what an absolutely tremendous and outstanding difference this is. Nobody can do that. But we can make an analogy. We can get a sort of a glimpse of this enormous difference in mentality between these beings and us. And this you can do by comparing us, who have gone to the moon, to beings which lived on Earth 1 billion years ago, and these were little one-celled animals swimming in the ocean. So the difference between them and us is comparable to the difference between us and a one-celled animal swimming in the ocean. So in this orders of magnitudes, you have to consider extraterrestrial civilizations. Now, therefore, we find, okay, I forgot one thing. Now these guys who have lived a billion years longer than we, yeah, they have done science not only 1,000 years like we did, or 1,000,000 years. They have done science 1,000,000,000 years longer. Therefore, there must be absolutely omniscience, omnipotence, immortal. Well, not completely, not like God, but they must be very, very much more knowledgeable. Okay, so we have what we know about extraterrestrial civilization is almost infinite knowledge, almost infinite power, immortal. Can we say something about the body forms of them? Well, here you see a part of the human genome. You remember that a few years ago the human genome has been deciphered, and it's a book of a length of 3.5 times 10 to the 9 letters, and these are the type of letters which come here in sequence, split up in 46 chromosomes. Now, body size. When we and we are pretty much at the moment about to understand that about 20,000 to 25,000 genes composed of these genome sequence. And once we have understood the information, which is really finite, I mean, you should only understand about 25,000 genes and what they are doing, you will, there will be a stretch in these genome sequence which tell you the construction plan of a human brain. And once you have found out the construction plan of anything, yeah, it will not rest there. You will try to build this in computer technology. That means we can foresee that in a short time, maybe 100 years only, we will be able to construct humanoid creatures which are fully as capable mentally as we. And therefore, if you talk about what body size you expect on another planet, even in that very short time you will find they might be inorganic, miniaturized, and you might even have a free choice of your body. Can we ask other questions like what would be the average lifespan of such a civilization? Can we estimate the number of these civilizations present in our galaxy? In order to do that, we have to think about the dangers, because many of these intelligent civilizations might get extinct because of some dangers befalling their planet. We know that 65 million years ago there was this asteroid which impacted Earth and killed all the dinosaurs except for the birds. This has recently been affirmed that this is a real reason for killing the dinosaurs. Just now in a few months, 1 month ago or so, in Nature or in Science, there was a big review article which confirms this cause for the end of the Cretaceous time. But there could be also plagues going on, some virus which kills all of man. This has also been observed in animal kingdom, that some guys vanish because of this. Environmental destruction and so on. There are these external dangers. I don't think these are the real dangers. The real dangers, we could now do something about the asteroid impact and so on, and about this other thing. We can isolate ourselves. I think the real dangers come from ourselves. That some super Hitler or super Bin Laden makes himself to be the most important, the most famous man in history by killing the human race. Yes, this could happen. And the problem is, the more we know, the more dangerous, the more this danger grows along. Yeah, that one mentally unstable person endangers the whole society. Now, let us estimate the lifetime of an intelligent civilization. I told you already that there could be intelligent beings which are 1 billion years older than we. So the optimist says, well, they have managed somehow to get these Bin Ladens out of the system and to kill them before they can do any damage. There are also pessimists which say, well, we might make it another 100 years, but that will be the most, maybe 1,000 years, then we will kill ourselves. And these are the pessimists. But as human beings already lived for 2 million years, so this number would be 10 to the 6 years. So you have these two boundary numbers to play with. And you can say, okay, let's make a logarithmic mean of these two and be a little bit pessimistic. So 10 to the 7 would be sort of a normal, would be a good guess for the lifetime of an intelligent civilization. Now I want to tell you what this means. Here again you have the lifetime of our universe, 13 billion years. And we have said that, and here is the number of planets plotted at the ordinate, and here are the first Earth-like planets being born, and then today we have 4 times 10 to the 6. Now, in this first time, there is no intelligence around, Earth's human time intelligence, so the first intelligent beings would be born here. But they only would live for 10 to the 7 years, which is not even the thickness of this line here, because this distance here between these two lines is 10 to the 9 years. Yeah? So very quickly they die, and then new ones are born, and they die again, and so on. And all this blue area has seen intelligent beings, but they all killed themselves. So only this last green thing and this green thing is sort of enlarged to be visible, and only this part here, they still survive. These 4,000, you can come with to 4,000 if you do the calculation. So there should be 4,000 intelligent beings, civilizations present in the galaxy at the present time. But this is naturally a very, very rough argument. Now, let me come again. Okay, we have answered these questions. Let me now look at the 2 more questions. How far away are they? Is space travel possible? Can they identify our home planet? Because we have this enormous number of stars in our galaxy. Can they find us? And this is a question which Mr. Hawkins has just recently been discussing, and are they interested in us? Well, one thing is very easily answered. This is our galaxy, a box which a diameter of 100,000 light years and a thickness of 1,300 light years. And if you throw 4,000 planets into this box and say what is the mean distance between individual planets, you come up with 1,700 light years. And that tells you why SETI has not been successful. Because, I mean, they can only look a few hundred light years, that's all they can do. Yeah? And therefore, if the next civilization is 700 light years away, it's no chance at the present time to observe these intelligent beings. Now, the other question is, can they find us? Well, I think that they know exactly where we are. There is no problem. Such an intelligent civilization will not know where we are. So there must be other reasons why they have not contacted us. First, I will show you why they know that where we are. This is infrared spectra of the planets of the inner solar system taken by Cassini, this spacecraft which investigated Jupiter and then afterwards Saturn. And you see in all these planetary atmospheres there is a very deep absorption band of CO2, which is clear because Venus is mainly CO2 atmosphere, and Mars also has a lot of CO2, and Earth has also CO2. So that's expected. But on Earth you find other things, like you find water vapor bands, and these water vapor bands were there already 4.4 billion years. So these extraterrestrial intelligence would know since 4.4 billion years ago that there could be life on Earth. But they find ozone. Ozone is absolutely identification for life. And because only when you have life can you have ozone in the atmosphere, and this is known since 2.5 billion years, all in our galaxy, and therefore there is no way in which they wouldn't know where we are. Now I come to my last slide. Why don't we have contact? The so-called Fermi paradox. We have learned that extraterrestrial intelligent civilizations, compared to us, must be almost omniscient. Compared to us, have an unimaginably advanced technological power, so there is no problem contacting or visiting us. There is absolutely no problem. So also the idea of Hawking that we should hide, I mean, is ridiculous. I mean, there are great men and have great ideas, but some can also make mistakes, yes. But the problem is, the very advanced knowledge also means they are in extreme danger of self-destruction. There could be one unstable individual in danger of the whole civilization. And therefore, if they survive this danger, they should have formed a very stable, responsible civilization to master this danger. And this is the idea behind the so-called zoo hypothesis, pronounced by Bohr and Sagan, that they don't want to contact us. And why is this? Because a contact, if you think about it, would be very irresponsible. As irresponsible as the behavior of these guys like Columbus and all these other conquistadors in South America who essentially demolished all the native populations and civilizations there. Just think what would happen if we had contact with such an advanced civilization. We would need to forget all of physics. Yeah? Einstein would mean nothing. Yeah? Because they have guys who have been there billions of years more, and we would have to learn all the luminaries of their civilization. So all of our we could forget about almost everything. Even musicians, they have much bigger ones, very likely, and so on. So essentially, our own development would be cut off completely, and this is utterly irresponsible. Okay, let me summarize. And yes, and because it is so irresponsible, it cannot be expected of them. Because if they were that irresponsible, they would kill themselves immediately. I mean, there is no way in which an irresponsible civilization would survive this danger of self-destruction. So the summary, in summary, I have told you extraterrestrial intelligent beings exist. They avoid all contacts. That's the reason these UFO reports are nonsense. But I think they observe us. Because intelligent civilizations are the only interesting things in our galaxy. I mean, they know black holes, they know interesting red giants, they know prometheus and corona. That's long known to them. But intelligent societies are individualistic. They, each one might be very different and have a very different outcome. Because in the development of this civilization, it's the free will and intelligence involved. And so they might go in very different directions. So these are the most interesting things, and therefore well worth, and there are only a few of them in the galaxy, so that I think we are very interesting things to observe. And actually, and now to think, I might actually have, go over my head and become sort of a little crazy, a little, because I maintain they are here on Earth. These extraterrestrial intelligent beings are somewhere here in the solar system, but very likely on Earth here. So why is this? Why do I say this? There is one possibility, one thing why they might interact with us. Just think, if you were somewhere observing a civilization somewhere for millions of years, and then suddenly you see there is this people coming along, this super Hitler wanting to press a red button, and then your experiment is gone. You don't know what will come out of this civilization. So this would be the one thing where these guys change this guy a little bit and therefore prevent us from committing suicide. And to see what's coming out of us in the future, in the next 100 million years or something like that. And in order to prevent us from committing suicide, they must be here. It doesn't help you if you are 10 light years away. I mean, and it takes all this time to come here. By that time, the whole thing has been done, the destruction. So they must be here to intervene. So this is the only logic which lets me think that they might be here. Thank you very much for your attention.
Peter, thank you so much. This is great stuff. It was fantastic. I really enjoyed the talk, and I hope everybody enjoyed it. Well, people may have different opinions about some things, but it's natural. After all the civilizations, they have a different way of thinking, perhaps.
Yes.
Yeah. So let's take a few questions if there are.
Yes.
Congratulations again. The 06 factor in population 1, you placed in Drake's equation, all right?
Yes.
You talked about the chemical and in short term, the matter that supports this life. Anyway.
Yes, I just wanted to say 60% of the stars of our galaxy are population 1 stars. These are mainly the stars in the galactic plane. The ones in the halo are population 2, and also most of the ones in the bulge. But most stars in the galactic plane are population 1 stars, and a rough factor is 60% of the stars of our galaxy must be population 1 chemical abundance. Okay, you continue. You wanted to ask something else.
You covered me, but the end of it is we're talking about carbon or organic life.
Yes.
And only, right? Not
Yes.
Silicon, not... and I guess these materials exist in the population you referred.
Well, the thing is, there have been big books written about is there also life possible on the basis of silicon, and silicon does not mean computer technology, It means really life having form by nature on basis of silicon. This has been carefully considered. And it's found that carbon is absolutely unique because today we know 20 million carbon compounds compared to about 200,000 compounds of all the other elements together. So carbon is absolutely unique in this respect, irrespective of how high the temperature is, you know, in cold temperature, high temperature, and so on. So it is very likely if you build life, nature will use this building material which is the most versatile, and that will be organic. So I believe that if there was life formed anywhere else, it will also be formed, started off with organic chemistry. Because of just the absolutely abundance of this material. Thank you.
Yes.
Yes.
You assume that there are a number of habitable planets in our galaxy, and you assume that our galaxy is a cylinder, and the average distance is about 1700 light years. Yes?
Yes.
Okay. Don't we have to consider that there must be a galactic habitable zone?
Oh yes, yes, yes. This is Lineweaver's ideas and so on. I understand. I mean, I didn't want to go that much into detail. Yes, it's right. Yeah, they are talking about a certain distance in which.
From the center of the galaxy.
Yes, 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 yes. There are these. This makes the whole thing not drastically different, but one has to go more into details to taking this into account. I agree with you. One can, paint this picture with more colors, and things become a little more complicated. I just did an order of magnitude type of Fahrenheit estimate.
Just can we go to the conclusions?
Yes, yes, yes.
It's interesting. The first conclusion that extraterrestrial intelligence and beings exist. I'm convinced,
yes.
Personally,
yes.
Okay, as an astrophysicist. The other three, however,
yes.
I'm not quite convinced why you say they avoid all contacts. Does it mean among themselves or contact from our civilization which is inferior to them? What do you mean avoid contacts? Can you explain again, please? Because I
yes. Yes, yes, yes. First of all, I think they avoid not only us, contact with us, but also with other civilizations. But how? The thing is this contact cannot be avoided under all circumstances.
Yeah, but
You see the following thing. I made an example. Since the 1920s, we send out radio waves. Okay? And these radio waves, let's make an extreme example. In 2 million years, we'll have reached Andromeda Nebula. And somebody from Andromeda Nebula will see these radio waves, will listen to it, and know, there is this intelligent civilization. So the contact, there will be contact, but it will be a one-way contact. Because if they answer, their answer comes back 4 million years later. There will be no discussion going on between these things. You can make similar thoughts and think about how, because all these radio waves will also have gone through our galaxy, and there might be, you should think about at what stage are these 4,000 estimated intelligent beings, and what will they do? In my book I have done some of this thinking, whether, you see that the trouble is, will we be, when will we on Earth adopt this policy that we will not contact other human beings? Will this zoo hypothesis, when will it be installed as policy here on Earth? Yeah? I suppose it will take a few hundred years till this will be an absolute policy being instituted on Earth. It will be a time when we have realized that we will kill ourselves if we continue with these type of dictators which are around at the present time. We will have found something to prevent and take them out. You know, today it's almost impossible to take one of these dictators out of circulation. You know, you cannot somehow track them and so on. So it will take some time. But by that time, when is another civilization of these 4,000 in our level, and that we could have some contact with them? It will take, you see, all these habitable planets start at slightly different times, yeah? And you can calculate what is the mean distance between our civilization and the one immediately following us in development and immediately in front of us. And there is many thousands of years difference. And these thousands of years will be just these times in which this solar hypothesis will take effect. So there are many questions of this type which one can ponder. But I think eventually we will have not, it cannot be completely brilliant. For instance, if we will do space travel, and you can calculate, if you have that many dead civilizations in our galaxy, as I calculated, almost all are dead, you know, of the 4 million or so planets which have developed intelligence, or 2 million planets at least, most are dead. You can throw 4 million or 2 million planets in this box of our galaxy and then look at the mean distance between failed civilizations. And you will find it's only 200 light years, yeah? And 200 light years would be some distance which could be done with space travel. So you might find a failed civilization in 200 light years distance. You could go to that planet and see, there was a famous civilization, but it killed itself. But we could do a lot of archaeology and find out what they knew and what they had learned and so on. They're great scientists and libraries and what else. So there is a lot of this thinking which one can do and possibilities.
Okay, so summarize my point.
Yes?
Okay. I was just thinking that if the extraterrestrial civilization is that developed, they must have mastered traveling, right? So sending a message to us wouldn't be that hard, because they wouldn't send it from there, from 5,000 years of light. They would have sent it nearer to us.
Yes.
So what I would like to ask is, did you know something about the wow signal? Have you known about it?
Yes.
And what is it?
This was discovered in a radio. It was a radio message which had this wow type of thing, but it was only discovered once. And
What is your assumption of that?
well, you know, when you have events which occur only once, yeah, and you all know, I mean, I'm a theoretical physicist, okay? And I mistrust all theoretical programs because I have had all my life, I played with big computer codes, and I know how easy it is to make mistakes. And I have heard the following thing, which I think is quite true. Everybody believes that theoretical physicists more than the theoretical physicists themselves, because they know how easy it is to have a bug in your computer code, and which you then later have to retract all your great conclusions to make it point. And the other side is also correct. If you are a great experimentalist, building of radio telescopes, you also are aware of how many errors and how many false observations you can get by doing observations. I just recall the idea of flare stars, which our French colleagues I think in somewhere, no, it was in southern France, in some observatory. They had suddenly all these many flare stars discovered. They had this very sensitive instrument in their dome, yeah? And then suddenly they realized whenever there was a cigarette being lit, you know, they had a flare star, yeah? So the light of lighting a cigarette, yeah, produced a flare star because the instrument was so sensitive. So I would say, if you had an observation which only occurred once, it could be so many things. You could only, in such an important thing like discovering another civilization, you would need to have multiple confirmations of this. And this is typically what physicists demand of you. So I would not play this one wow observation as being significant.
But the story with the discovery of the magnetic monopole.
Yes.
Just one announcement then, it was not found again, and died. So in physics, we have to experiment several times. Yeah.
I have a countryman called Schön, who produced 6 nature papers per year. He was at the front thing, and he was even considered as to be the head of the Max Planck Institute in Germany, until it was found that all these papers were produced by him, you know, the data were all dreamed up by him and published in Nature. Yeah? So he had to retrieve everything, and I don't know when he's vanished. Nobody hears from him again, you know. He's John Philipp Schön. So there was a lot of fraud also involved in science. Unfortunately, we should not do that, but this is the thing.
Yeah. So, back to this one, the last 3 points on your slide
Yes.
are conceptions, right?
Yes.
I consider the first one almost solid, okay, I accept it.
Yes.
But the 3, and for example, how do we know that they are, of course we say problem, but how do we know that they are here? I mean, is there any evidence? I'm not talking about proof.
Now, I started off my talk with saying that no evidence has ever been found. You see, you can always give a proof for this. Because, you know, if you have an external civilization visiting us, and you in Greece must know what it is to be visited, yeah, by tourists, yeah. And if such a tourist, yeah, coming from another star, comes here, a whole group of them, I mean, they must have flown and fought for a long time, you know, thousands of years in their spaceship, yeah. You know, you might actually lose something very nice. You know, you always leave something behind. You know, tourists leave always some gadgets or something laying around which they forget. And if you find this thing, and it can be shown that this cannot possibly be manufactured by human beings, You can see what you get, how much money you can get from this by going to an international auction. I mean, it's quite clear that Mr. Bill Gates would try to get this gadget to improve his company, you know, and to decipher what is the physics in there, which I can copy here, and something like that. So it would be billions of dollars worth, yeah, to have this thing here in an international auction. And nobody sitting here would ever refuse to have €1 billion in one's bank account. I mean, I personally must admit to have €1 billion on my bank account would be so great. I would like it, and I think nobody of you would refuse it. So, because it never happened, yeah? It never happened that somebody came and showed a gadget which cannot be of human manufacture. These external tourists probably have never been here. But this is not a real big proof. It's just an indication. Yeah? Okay.
Okay. There is a question by...
No question, a comment. First, congratulations for your nice lecture. It was very interesting. My comment is that I agree with Canaris about the 3 points.
Yes.
So I cannot believe that. I have doubts about the validity of this, since they are not based on observable facts.
Yeah, sure. That's very true. But the thing is, we do have to answer. If you believe this, you have to answer the Fermi paradox. I mean, the great physicist Enrico Fermi in Los Alamos in the 1950s, he just asked this question. Well, you guys, if you convince me that there are so many intelligent beings around in the galaxy, yeah, why have they not listed here? Why have they not shown themselves? Yeah? This Fermi paradox, yeah, has to be answered. Well, we can say, okay, they killed themselves. All of them killed themselves, yeah? So there are none of them survived. But I don't believe this is a good answer, because I believe some will have survived. I mean, of even these billion-year-old civilizations, I don't believe everyone automatically kills itself. It would be a law of nature, yeah? That an intelligent civilization will always kill itself. I mean, I don't believe in this automatic thing. I believe some will kill themselves and some won't. Yeah? And therefore, I think they are still around. But why there have been no contact with them then? Yeah? And I think this is really a very suggestive hypothesis, this new hypothesis. If you think about it more and more, it becomes more and more convincing to you that this might be the case. And then, Canaris, you might even get convinced about these things. Maybe not about the last thing, but because the last thing is a little bit counter my argument. Because if you prevent all these self-destructions, yeah, then you are again in a situation that you have all these very many intelligent civilizations, like 4 million in this galaxy, and then you really have the problem why you have no contact. Yeah? So I just say it might be possible that there are some remaining self-destruction, because you don't like to kill your experiment. I mean, you go to Africa, you would not like to have a pack of lions which you study suddenly be killed because of some a virus or something like this attacking them. So you would remove an animal which obviously was killed by a virus or something like this, and would kill all the study group. Yeah? And so it happens with studies of apes and so on. So you wouldn't like to have your experiment being disturbed in such a bad way. Okay.
Okay.
So I think that there is logic in it, but I agree with you. You cannot do any proof. You cannot prove it.
I fully agree with your logic.
Yes.
And if they have good intentions, I would like them to be here in order to prevent global annihilation, because it seems that we, our civilization, we suffer, as you say, more from internal disasters than from external.
Yes.
So, but there is a need. If they have good civilization, Hawking says that perhaps they don't have good intentions. So, it's better.
This is the problem.
This is the problem. We don't know if they have good. There are 50% chance.
But my logic is if they have bad intentions, they have also bad intentions to themselves. I mean, if you have a bad person, he might also, try to kill your own kind, yeah? And we have many of these guys. And also guys who want to just become famous. There was this guy in Ephesus, I think Herostratus or something, and he became very famous in burning down the greatest temple of that time in antiquity, the Artemis temple in Ephesus, yeah, because he just he tried to become famous, yeah. It's like Hitler, he would have liked to destroy all of Europe, or something like this. I mean, these guys we have to remove from our society. But how do we do this? This will be the challenge of the future, how to actually take out all these misfits.
Okay, great. I think it's lots of food for thought for us. And this is one component everybody asks us in the radio, in public, etc., about astrophysics. So we have to think about this and try to find ways to answer this kind of questions. Well, thank you very much, Peter. It was a great talk.